morning, everybody, and welcome to our session today. Our webinar is focusing on essentially the journey that's happening out there today with our data and the application of that, whether it's on-prem or in the cloud, kind of the best practices and principles around the workflow that we see today happening as that data, which becomes very, very important to us, is kept and utilized. My name is Kevin Clements. We're here with WebAge Solutions, and we're looking at the DevOps to DataOps to MLOps journey in 2022. So the state of things as it appears today. Just a couple of reminders during the session. Feel free to enter questions into the chat. Be more than happy to answer and clarify anything that you may have questions about. Also, with regards to the session itself, there is a handout. It is in the handout section, but you will receive it as an email link at the end of these sessions as well. So again, welcome everybody. Nice to have you with us this morning. And from the point of view of the session itself, we are...
Good morning, Kevin. Sorry, in my screen it shows that you haven't started the broadcast.
Yeah, it started.
It's already started. Okay.
Yeah.
Perfect.
Yeah. Yeah. So it was started there, but all right.
Okay.
So again, folks, welcome to the session. Nice to have you here, and we're going to be looking at this journey as we kind of continue through and see what's happening as far as the state of these various technologies are delivering today. Hopefully everybody has their copy of the session as well. Okay, as far as the tools and so on, we're going to kind of break down what's happening out there in the state of the current settings within DevOps, within DataOps and MLOps, and we'll talk about where things are headed. We'll look at some of the tools that are being utilized as well, and we'll try to define the existence of why this is happening. Why are we seeing this trend not only here in DevOps but in DataOps and in MLOps to move into a more agile environment? What do we mean by that? And so on. We'll define those things as we go. We know that over time, DevOps has certainly developed and changed, and it's come as a result of a number of different things happening in the industry. If we look at where we started even 20 years ago, as we started to move into kind of this idea of agile platforms from the idea of sort of the waterfall effect, what we've seen is a trend to have collaboration be more prevalent in organizations. And that goes from kind of the dev side all the way through to the ops side. It's no longer just, create some code, throw it over the wall and, hope that something works. We've kind of done this idea of shifting to the left, and we'll talk more about what that is and how that affects organizations. But if you look at our ideas here, we're really talking about something that's fundamental today in organizations, and that's collaboration at all levels, bringing in the expertise of the individuals that we have on our teams, amalgamating them into finer, more performant operations, right? This is the idea of the management side helping to kind of guide where we're headed. We start with this idea of shift left, and that is that everybody starts talking to each other at the get-go. And we need to have that kind of foundation so that we have an understanding of the expectations of all team members. Instead of developing code, taking that code, putting it up somewhere for the dev team to manage, and then finally making it available to the ops team, and then security looking at it, we want to get things rolling as quick as possible. This, of course, leads us into continuous delivery, which is an important piece that we'll talk about. Tools out there today, we see a lot of them, whether it's something like Git, GitLab, GitHub, or whether it's the introduction of terms around the use of Jenkins and Jenkins pipelines and things like that. But we certainly have continuous delivery to think about. We've got reduction in the complexity of the components. A lot of that brought by the fact that we've moved from kind of writing driver code, at the very lowest level, things like mice and keyboards and network cards, into using classes and modules that make it quicker for us to get to those endpoints. And as well, because we can use that within the team environment, if somebody within our own environment is developing customized software, it's pretty easy to move that into the focus of other developers, right, to let them see what's happening. And this is the idea of sharing that. Obviously, overall, there's benefits to the business. We deliver things faster. That's always going to be a benefit to the business. But we have increased stability in the product as well, because we can track over time what's happened. We can see exactly where there's difficulties in the product delivery, where there's difficulties in the actual functionality of the products. We can very quickly turn the team and have them focus on those issues and resolve them in a quick way. And then finally, and probably the most important part of this is this knowledge sharing, right? The team now becomes more agile because everybody gets to see kind of what is part of those individual pieces that they may have not seen before. We're talking about cloud-based systems, right? We now have the ability to administrate and essentially load our environments in a manner that makes it easy for people to work with. And this is, again, an important feature that we have. It's the automation of those processes that goes one step further. And we've seen automation not only with things like GitLab and Jenkins, but we've seen automation on the ML side as well. And today, one of the new focuses that we're looking at is this idea of auto ML. We'll discuss that a little bit later in the class, but it's affecting all of these areas to ensure that what we're dealing with, our code, our data, rules and regulations, knowledge sharing, all of those things come together sort of in one way. And you can see that gives us that collaborative culture that we mentioned, but it also helps with the business with that time to market changeover, which we're kind of critical thinking about all of the time. This leads us, in at least the DevOps world, to come up with some ideas around, and you may have heard these terms before, what we call A3 and C, and that is accountability, automation, analytics, along with that collaborative culture that we're so interested in. If we could then take that and move it to other areas, it makes sense that things like accountability and automation and the idea of analyzing what's happening can fit nicely into things like our DevOps teams and our MLOps teams. And further, of course, we could go further with this to AI ops and some of the other operations that are coming into focus in the last, I would say in the last 5 years in particular, since Gartner released a lot of its studies around these areas. It's become more prevalent, and certainly people out there are more aware of these methodologies that can be applied to other fields within the organization. You can see there, knowledge base. We're going to keep talking about knowledge base and the sharing of knowledge. We can do that in many ways. Often that's done in the Agile environment by sharing as a team, where we're at, what issues we're having, tracking those issues, right? And then auditing that going forward. When we get to the DataOps side, it's done very similar. We set up data governance, we set up some kind of what we call master data management, and then we're able to audit what's happening within the organization, even if we take a cloud first approach, which we'll mention. And when we get into MLOps, it's even more critical because today about 62% of all MLOps projects actually fail, and they fail because of that lack of integration between what we would have on our, kind of a local desktop that the data scientist or the data engineer is using versus when we move into the cloud space. There's a gap there that we need to think about and how to fulfill that gap so that we can be more successful. Again, everything around technology, right? We need to have a clear understanding of how those things fit together. For those of you that may not be familiar with DevOps itself, there's a couple of key areas here that we want to discuss. We're moving away from what we call siloed environments. In other words, the DevOps team works on its own. There's no integration with other teams, and all of a sudden they're finished. And as we said earlier, the product is kind of thrown over the wall. We don't want that to happen. What we want to do is have transparency, and that's really what we see here as keys, along with this idea of automation. So how do we do that? How do we go from kind of that siloed environment into a more transparent methodology? One of the things that we start off with is, and maybe as a developer or a manager, you expect some kind of notation from your developers. And of course, as a developer, this is generally an expectation of something that you would deliver, and that is documentation. Very simple documentation within code. This is an example of that. So you can see here at the top, we've kind of got the who, what, when, where, why that is very, very important around the development phase. So who developed it? When did they develop it? Why did they develop it? What was developed? And of course, if we start going into the how, that's the code breakdown, and there should be, some kind of declaration around what the code is doing. But this was kind of the simplest form. This is where we started off, 30 years ago, even 20 years ago. It was still quite prevalent because we didn't have a lot of systems out there for that idea of source control, right? Subversion, Bitbucket, Mercurial, we mentioned Git, GitLab, GitHub have all developed over time so that the code that we're developing can be checked in somewhere and others can make use of it. But without this key area of information, we may be lost. Today, a lot of these products, I mentioned GitLab, GitHub, and so on, they allow for this to be done on an easier manner, and that's simply by using the check-in tools that are available. A couple of examples of that. I've got one example here in GitLab just to kind of make a kind of an overview example for you. You can see that there's different projects. These are just example projects, folks. You can see we can get indications of maybe something going wrong. We can also see if we go into one of the branches, let's pick the tutorial, I guess. Doesn't really matter. We can see what's sort of going on, how many commitments are going on, how many branches there are. And we'll discuss these branches in more detail. There's generally a master or main branch that's part of the release. Underlying that in DevOps, you would generally have hot fixes and so on. Then you would get into the development branch. Then you'd get into the feature bus, maybe because of some kind of security issue, or maybe because there's a new feature that we're looking for. But the idea in the process is that we can get this information, right? We have essentially an audit tool that allows us to see what's happening. And there are other ways of doing that through this process. This is GitLab, which is one of the more prevalent tools used today. You'll see that it also supports this idea of CI/CD, which we'll talk about shortly. Other tools are as detailed as that. This is another example where you might see something like this, and this is GitHub. And within GitHub, owned by Microsoft, of course, and part of their Azure platform, you can see the breakdown here of kind of the teams that are involved, what changes they're making. We can see when those changes were implemented, we can see what's changed. And again, we can look at, of course, different branches as we need to understand what's happening within the development process. So this is actually a branch for the CDK components, the Cloud Development Kit within AWS. And this is the actual folks writing that behind the scenes code that's used by teams to deploy not only their code, but their data as well. We'll see an example of that coming up when we get into DataOps. But you know, again, one of the ways that this can be organized. Again, being able to look at a specific branch, what was committed, what was changed, you know, how much information, you know, all of this. I'm just not connected at the moment. That's why it's giving me the errors there. But this will certainly give us a, you know, quick way to understand what's kind of happening within the organization using this kind of repository for the source of our application. And again, just to give you kind of a full screen view, this would be more likely of, you know, what you would look at. If we compare that to GitLab, again, very similar. We can go into the project information. We can see the activity that's being done. You know, on a basic level, we can look at the team information, any issues. All of this gives us one location to be able to understand what's essentially happening in the overall project. So that's kind of the mentioned is the ability to analyze when there's failures, when there's successes within the application. We can monitor application deployments, things like that. We could also get notifications when, you know, a new branch is available for moving up perhaps into a release branch. All of these things can be tied together. Leadership, of course, can get a quick look at what's going on from an organizational standpoint. They know exactly where you know, the code stands at this point in time. We can see this also kind of show that, but there are analytics that are provided to us in a more graphic way. Unfortunately, there's not enough data in this one, but we can certainly go in and, you know, kind of look at the different stages of that and get some value stream information behind that. Now, again, this is GitLab, which does both CI/CD processes. And then finally, we've got this term that we keep hearing a lot about, and that is microservices. Microservices being handled today in a lot of cases through something like Docker, where we utilize our small applications that will be provisioned through the Docker container, and then in order to, you know, be able to have that effectively work, we would look at using that probably in a cloud-based environment, although on-prem Kubernetes is perfectly fine. Kubernetes is the orchestration to be enough interaction with, you know, the data stores and so on, all governed through that sort of end. Big change that we're seeing overall. A couple of other things just to be aware of, you know, the goals we mentioned before, the idea of shift left, that's rapid identification, right, of defects so that we know where those defects may be and we can quickly deal with them as required. We can see that we mentioned, but I do want to look at these two in particular because the goal of any project, right, is to deliver satisfaction to applications or quality products that we're delivering. So, you know, the idea of the two of them working together because the product or service may be there, and of course the idea of improving customer satisfaction out of that and using DevOps in this way, we also get that agility where we can move developers around to meet the needs of the requirement. And this gives, of course, that team collaboration environment, as we mentioned. We also have typically people that are less stressed. They know exactly what they need. Versus in the team that they can talk to and even reach out to other teams as required. So this environment for collaboration is, as we said, very, very important overall in the organization. Here's an example from the point of view of what's actually happening out there, and something that you'll see on this one is the complexity of the data. We'll talk a little bit more about that in DataOps, but we've seen a huge uptake in the amount of data that we're dealing with, not only from a volume point of view, but in the variety of data that we're dealing with. It's not just text files or database files anymore. It's video, audio, it's streaming social media, all of these things that need to be gathered by the organization and analyzed and understood, especially with the relationships. And then, of course, the volume of the changes that we've been doing down at kind of the small end, and it's not meant to be that, but here in at least the example down at the small end here, we have customer sales management. All of those things are important areas where we are looking at information to be utilized by the organization in some way. And then we see above that, the tools that are actually used in what we now refer to as Web 2.0. Again, this is something that we need to be we are using today, and it's interesting to see what's happening in those realms. We'll talk more about the collection of that information. Again, throughout this, we have to think about governance. Talk about that the data side, but in particular, IT governance and data governance around security, privacy, all of the things that are very important to the organization's reputation. Right? We have to maintain that simply because there are regulatory policies that we need to be aware of. But the idea that we're collecting more data, yeah, absolutely, right? Exabytes of data now, beyond even petabytes of data. I mentioned IT governance, and IT governance again is an important piece to understand. This is IT management of resources so that it aligns with the business requirements or the strategic business requirements that we have and that we're trying to accomplish within the organization. Lots of tools out there today. We've got Corbett and ITIL, of course, mentioned down here is some of the major frameworks. Really what we're looking for is the decisions that need to be made for the benefit of that IT investment. Do we want to go out and order from Dell or IBM 100 machines, and we're going to get those in probably February, March right now because of supply issues? Or do we go immediately to AWS or Azure or Google and spin up those resources? What's the cost of that versus the capital outlay that we would have had for ordering our own machines? Or maybe we do have, right? We have immediate needs. We try to do those in the cloud so that those needs can be met, but we're still expecting our own on-prem systems at some place. Of course, somebody has to be accountable for that. So the decision making's been done. We need to ensure that costing is appropriate, and of course the decisions around the implementation, well, we're not just done once we implement it. We also need to think about monitoring and measuring those over time, right? What's the cost ongoing? Where do we see spikes happening? Things like that within the organization. So we've got that governance to think about from the perspective of managing those resources wherever they may be, cloud or on-prem. Of course, some of the practice around that is mitigating risks looking at the outcomes, right? Making sure that those are predictable. And of course, measuring, as we just mentioned, the performance of that. We don't want to place constraints on everything, but we need to be thinking about how all of this fits together for the organization overall, and ensuring that somebody is responsible for that. I think that's one of the biggest gaps that we have today, is often that when we place those decisions constraints, we don't empower people within the organization to be able to modify those decisions, or give them enough authority to make decisions on the fly. And I think this is something that IT governance really does help with overall. Of course, what are the control, the guides, and all of the other things that are going to influence that. And then this is the most important one: what happens when there's an issue? Right? What happens when there's some kind of non-conformance? Could be to a regulatory policy, think Sarbanes-Oxley, think HIPAA. There is a whole bunch of other ones that we may be involved with. And then on the other side, within the government organization, there's FedRAMP and FIPS and all of those other policies that we need to know about, and then practice properly. Again, within the notes, you'll see more information about that. We don't want draconian enforcement, but we certainly need to have a balance that allows the organization to prosper going forward, and is forward-looking in itself, so that the organization itself can take advantage of what's coming down the road, next month, next year, 18 months out, right? Where our planning sessions are saying, well, this is the targets that we need to hit in 2024. Right? As a CEO, that's very important to me. So I look at it from that perspective of what are the targets, what do we need to have in place, and then I reach out to my team and say, what pieces do you need to be able to make these things happen? Once we have that kind of collaboration going on, we can say, okay, we need to look at dollar amounts for this, dollar amounts for other areas of our strategic growth for the organization. Martin Fowler, by the way, started this whole idea of DevOps, and he specifically talked about something called continuous delivery. This is, of course, from a software development perspective, as it says, building out the software, making sure it can be released at any time as required by production. And of course, that can be critical to the organization, especially when we are looking at areas like security holes or other types of issues where there is risk involved. And so the idea here in Fowler's software development lifecycle was essentially to come up with a way where we know what the goals are, we can sustain that work towards the goal with some kind of agility, being able to move members around in the team to meet the needs or requirements, and of course, being able to repeat that, right, for the next project or the next sort of jump, as we often call it. In rugby terms, you'll hear it. We have a scrum, and then we're looking to get to the next part of that provisioning of our application. To do so, CD often uses this idea of pipelining. For those of you that, again, may not be aware of that, we do use similar pipelines in other types of operations, and we'll talk about that around DataOps and MLOps. But the idea is we build some kind of application, we make sure that the code works. You may hear that as unit testing, integration testing, quality control, testing, and user acceptance testing, but some kind of static code analysis for performance, but as well, here in the testing idea, those kind of go together, at least at the basic level. And then we've got continuous integration, the idea with continuous development that we integrate the code changes that we've done or our data changes that we've done, and we make that available for release and deployment. So these are kind of the pipelines that we would look at throughout, right? So at the lowest level, you know, we're probably looking at configuring the environments. We're then looking at ensuring that everybody across the team has the same environment. Often today, we will, at least in my organization, use Docker. We gather together the requirements for what the developers will need. We'll build a Docker container with those specific pieces of software. It, you know, might be something like Python or C# or Java, you know, a particular version. We'll then look at the modules that are required, ensure that those are installed. We'll look at any other components that are required, like databases, you know, anything that today is going to be integrated with the code in that development process. That'll all be packaged in a Docker container. Then the developer simply has to download that Docker container, and everything is now available for them to start their piece of the project. This makes it easy to package things like changes when code is updated or when the underlying software gets updated. We simply do it in one location inside of Docker. Of course, our repository has the code, so those two can be amalgamated together. And now that developer has the latest version of the code with the latest software, including new modules that may have been added. But we have a single kind of source of truth for them to work from, both in where the data is stored, perhaps in, you know, Git, GitLab, GitHub, Mercurial, Bitbucket, whatever the team is using, and then pulling from Docker essentially the platform that they're going to create that code from, including, you know, the IDEs or Jupyter notebooks or whatever it is that's required. This is kind of the idea of that. So what we're really talking about is changes to the code on a daily basis. That's checked in. Integration is tested from an automated build, and then essentially what we get is that agility and reliability. So you can see here in kind of the example, we might be down here at the development branch developing some new software with some new features. You know, as those developments are, you know, coming to fruition, we check those in, and we can push them up to a release that can then be, you know, the new version of our software. Again, most of those tools I mentioned do have some kind of built-in visualizations. Gitflow is quite common for this. But we could also use other tools as well. One of the more prevalent ones that's been around for a long time is Jenkins. It's a, you know, essentially a CD/CI tool. It's got lots of plugins that people can work with, and it's pretty easy to utilize these plugins. And you can see there's a number of them to essentially build out your final project, including the audit trails that are often required. When I was talking about GitLab a moment ago, it's probably the most prevalent challenger to Jenkins today. And we do see a lot of organizations where they are now moving from the formal GitLab or moving to the formal GitLab adoption from using Jenkins for CI/CD or CDC, CI, depending on which way you go. And again, this is just kind of the forefront of where things are moving today. That's not to say there isn't stuff going on in the cloud as well, you know, whether it's the code pipeline in AWS or Azure's implementation of Code Builder. Google has others as well, where we can do the same thing, but everything is being developed in the cloud environment as opposed to on a local desktop or a local laptop by the end user. That software doesn't get installed there. It stays in the cloud, and they simply log into their cloud environment and run that code. All of the analytics side of things are also there for them to take advantage of. So it's a kind of a win-win environment there. CI pipelines, again, the real piece here, you'll notice it looks exactly the same as CD. The only difference is that we're generally talking about the final stages here where we are deploying the application and monitoring it. So in any of dependencies, things like that. You'll hear two terms used around typically development today, pipelines and workflows. Workflows are generally more specific to an application, whereas the pipeline is a more generic way to take from kind of the beginning stages to the final deployment stages and steps in between that we can, again, monitor, analyze, look at features and functionalities, make sure that they're meeting the requirements as we're building them up. Again, within that, there's a lot of tools out there. I mentioned different areas of this already. If we were looking at monitoring, we could do this on-prem with tools like Grafana, which is quite a well-known product. Grafana also works with Prometheus. They own that product. There's Graphite. There's a lot of monitoring tools available for us. We can transfer some of those to the cloud as well. Prometheus is available, or we can use the cloud providers tools. Think, as an example, AWS CloudWatch or AWS CloudTrail. Both of those able to audit who's touching the software or who's touching, various pieces of the application that's in the cloud. The automation process, as we just mentioned, with Jenkins or GitLab, or again in the cloud, we can do similar automation. Same thing with configuration management, and same thing with build management. Really, where we're getting advantages here is in the version control. Now, in the past, when we've done deployments like this with middleware, we've been able to have multiple versions of the software typically running at the same time. And with middleware products like WebSphere and WebLogic, we're able to kind of direct which consumer connects to which version, right? So that we can see whether or not, as we're releasing our new candidates, if they are robust enough, or if there's problematic issues that need to be corrected before we, let's say, officially release version 2. Version 1 still runs. Maybe we move 80% of the traffic to version 1. It's working away, and maybe 20% of the traffic to version 2. This gives us a good idea of all of those issues that may arise as we start to ramp up and have more users integrating, more customers integrating with those products. To do so, of course, we would need notification about that. And then the last little bullets here, we kind of touched on already, the idea of testing. Testing is done at all stages. It never finishes, including doing testing in the cloud environment, as we just said, with version control, deployment with middleware, or in some other methodologies. Again, in the cloud, similar ways of doing it. But the idea here of knowledge management, so we know exactly what's going on at all time. We've got the knowledge. That's captured. What we ended up happening in the late 90s and early 2000s is we had a lot of folks starting to retire that were part of that generation. I'm part of that generation too, but that was kind of the first sort of loss of knowledge in organizations. As people were retiring, the knowledge that they had about how things were working was unfortunately lost. Sometimes they were brought back as consultants to help fix that loss of knowledge. But today, using these tools, we can capture that knowledge in different ways, and be able to look at that and analyze that throughout the life cycle of the product. And remember, we're looking at a product life cycle here. Most product life cycles are between 6 and 18 months. If we went to organizations like Linux environments, Ubuntu, Red Hat, and so on, they have a 6 to 9 month window. You go to something like Microsoft, well, it's been a 24 month window. They're now shortening those down to about 12 months. That's at least the plan. And other environments would have similar deployment expectations for software. We mentioned orchestration. I did mention with Kubernetes the ability to move out these containers very quickly. That would be great on a single, distributed environment in one data center. If we need to go further than that, then we're probably going to want to have some kind of template that allows us to do that. It might be something like Helm. We might need to use other tools like Rancher to orchestrate at the data center to data center level. And there's a number of, again, depending on what we're doing out there, number of these tools that are available. For instance, if we were working with Kafka and queues, we would be talking about something called MirrorMaker that was built by LinkedIn that allowed them to do data center to data center amalgamation. So there's lots of orchestration tools. Whether it's in the cloud or whether it's on-prem through our VMs, certainly capable areas that we can take advantage of. All right, so really we've got kind of a checklist of things here, and I'll talk about a couple of them that I haven't mentioned coming up here. But the idea is that there is that life cycle. We know what that life cycle involves, some kind of time window. That time window is probably right now 6 to 9 months to 12 months to 18 months from product release to upgrades and so on that we're doing for the products. We want to focus on the end-to-end process so that we have a clear understanding of where there might be bottlenecks, where there might be issues. We need to have a clear understanding of how that is going to affect the delivery of the products. So using these tools that we mentioned for collaboration, whether it's ITIL or whether it's something like Jenkins or GitLab or GoCD, there's so many of them out there. This is an important collaborative tool that the organization should be adopting, and we'll talk again about others in DataOps and so on. We also have other tools that we can take advantage of today for the deployment of that resource, and infrastructure of code, of course, is a big area. One of the big tools out there that you'll hear about is Terraform. Terraform itself can be used on cloud platforms as well as on-prem platforms like VMware. And the idea here is that we can essentially build configuration files that allow us to deliver, and if we go into the registry here, we can see the different types of modules that are available for us and for the different providers. So this gives us kind of a single code base that we can use to deploy essentially to multi-cloud environments, whether that's a private cloud on-prem or whether that's public or hybrid clouds on AWS or Azure or Google or Oracle or Alibaba, or wherever it may be. These tools make it simpler to essentially get those resources up and running. And if we look at some of the the ideas behind this, it's pretty straightforward when it comes to solving problems that we've had in the past. And these problems aren't going away, unfortunately, anytime soon. But just to give you kind of an example of what we do here, we simply write either JSON or this is called HashiCorp language, HCL. It's kind of like YAML. We simply write a configuration file for the deployment of our resource. So this is an example of in Azure using the resource manager to deploy a Cosmo DB instance, or I suppose we could deploy many of them in a particular region, as you'll see. And again, that resource will have a resource group that it belongs to. It will have a unique name that I can then monitor within that resource group. And of course, I can then start to deploy my data to that database. The resource up and running in moments, not hours, certainly under couple of minutes for sure. And this is, of course, the advantage, right? If we need to quickly do this on AWS or any of the other platforms, then this becomes an easier way of deploying those kinds of instances. As opposed to, Puppet and Chef, where we actually have to write Python scripts to do that kind of operation. We now have the ability to do infrastructure as code in a more logical way. And the nice thing about that, again, that can be checked in, that can be shared. So if we have a group of people that are maintaining the software and need to make changes to it, that shared resource is made available. They can make the change to the configuration file and easily deploy that change for the overall project. Really, and we're doing it today, really we're talking about connected teams, and connected teams are being done with collaboration software in mind. We're not really talking about things like Zoom or Microsoft Teams or GoToMeeting, but those are collaborative tools that can be taken advantage of here, not only in the DevOps environment, but also in DataOps and MLOps, so that we're sharing the knowledge, which we mentioned earlier is probably one of the most important parts that we have to deliver. All right, so from a very standpoint of DevOps, then we talked about software value. Well, we're going to talk about the same values that we're interested in when it comes to working with data and the storage of data through the data lifecycle, and we're going to talk about that around MLOps. So you're going to see this come up in our next couple of sections, and we'll hear that term again and again. The software itself, well, that needs to be checked in someplace. It needs to be in a repository so we can access it. We're going to talk about the same thing when it comes to data. We're going to talk about the same thing when it comes to machine learning models, because those are the things that we do want to share for the organization. We've got this delivery chain, as it says, that's that pipeline. And again, when it comes to using this in the DataOps world, in the MLOps world, you're going to see that the pipelines are very, very important. They're crucial to not only delivering the product, but tracking from the point of view of where we're at within the project. And that's a very important thing, because we can optimize that by studying what went wrong, what went right. And again, these are parts of those deliverables. I can't stress enough this culture of values where we have a common deliverable, we have common ideals around getting to those endpoints. We can work together, collaborate. All of those pieces are, again, important here in the organization. And of course, we're doing that by using tools today, right? There are tools required, and there's going to be tools required for DataOps, and there's going to be tools required for MLOps. There's no way of getting around that. Today, we're not at the no-code, low-code layer yet, unfortunately. So somebody still has to write, the robustness that we need in whatever language and for whatever purpose it may be that we're trying to deliver to the production side. Okay, so a little switch into DataOps. So let's kind of set the groundwork. Really what we're talking about is data lifecycle. And DataOps is all about presenting us with methodologies to support that for the data analytics teams. Now, when we say the data analytics teams here, we are talking about a number of different folks in the organization that fit in that role. So let's think about what we said with regards to developers and administrators, and let's apply that here. So what do we have here? Well, we have teams of people that are dealing with data in some way, right? So it could be somebody as simple as somebody writing in the CRM tool like Salesforce, capturing information about the client, right? And they need to use that information for further sales. Where do we put that information? Well, today we tend to put it in a database, right? And Salesforce comes with MySQL, and that's the database that you use underlying for tracking information. Okay, great. There's some data there. What do we do with the data, right? So the idea is that the salesperson and other people on the sales team can look at that information and get a clear understanding of what's happening with that customer, right? They can look and see, okay, when were they contacted? What did they say? What are their timelines? And some of that is, kind of up to the salesperson to glean from conversations. But essentially, they have information that they've collected. Now let's go further. Let's think about the business itself, right? Sales is just one part of that business. There's other pieces within the organization that we need to know about. So where are we as far as development goes of the products that we are going to sell? Where are we as far as deployment of those products so that the salespeople can get them in the hands of the consumer? Where are we in the far as administration of those products? And is this going to be something that's going to run on the customer side, or is it something that we maintain? All of those things need to be considered. All of that involves different collection of data and working with data within the organization that we're exposing, right? If it's a customer and they're going to use the product, then we're collecting customer information. That's going to be an important thing to think about from the standpoint of data governance and the standpoint of master data management. We need to have somebody that can understand that data. And we often put that in the hands of the BI folks, the business intelligence folks, right? They're trying to glean information from what's happening within the business so that they can predict, window of 18 months or 36 months or whatever it may be for this specific organization. We've got the BA folks, business analyst folks, that are looking at the BI data and trying to do further analysis of it. We've got data analysts looking at data specifically as it's being brought into the organization. We've got folks that are data engineers that are moving that data around, possibly repairing the data as required, cleansing the data. These are all terms that we'll see coming up. And we've got finally, and probably the most important part of that, the data scientist that can give us overall, there is a cost in storing and processing and retiring data once it becomes obsolete pieces that are used within the organization as well, and we need to be aware of those. Okay, so just to keep that in mind as we're going through. DataOps itself borrows a lot of ideas from DevOps because of the fact that we still need some kind of process to monitor the life cycle of the data. Now, when we say that, how can data change, right? Well, let's take a very simple example. We build a table, and that table is basically customer information. Well, if we built that table 30 years ago, things have certainly changed in our lifetime about what we collect, right? Mobile phones were just coming online in kind of 88, 89 timeframe. I had a brick, as it was called back then. That was a new way of contacting somebody, right? Faxes, right, which were very prevalent for sending information even 20 years ago, are almost irrelevant today, although we now do faxing by electronic means, often by attaching things to email. We need to know the audit trail of that, right? Are the organizations keeping track of the data that's moving that way? That's an important area that can often lead to investigation via outside agencies. And we certainly don't want to be, Google or Amazon or some of the other major players out there that have been fined for moving data from where it should be to other locations. I'm thinking the European Union filing of 150 million, $250 million fines because some of those cloud agencies were moving data from Europe into the US, which is a violation of territorial policies of the European Union as well as the United States government. So Canadian government, all of the governments around the world have policies about where the data needs to live if it's generated there. Again, that's part of their privacy acts that you're probably aware of. What we've seen, of course, is this change, and it was an abrupt change that happened really in about 2018 when more tools started to become available for the capture of this data. There's a good kind of an example here of those individuals that I mentioned a moment ago that were touching the data at some point. So here the data engineers and the data stewards, again, could be BI folks, could be analysts. And then over here on the other side, data analysts and of course data scientists. And we can see that we've got a collaboration going on again, and it's key to ensuring that the organization is working effectively. And it's here around the data catalog. So who's producing the catalog of information? The schema about the data. Now, it goes a little bit further than that, because we're not just talking about data schema here, we're talking about reference data and metadata that was collected. You may recall that I already showed you some kind of concept around metadata being collected, and we saw that in the DataOps world by something that we used to do a long time ago directly in our files, but now we do it through the check-in processes that are part of things like Git and Bitbucket, Mercurial, and so on. It's the capture of that information, the metadata. Who did it? Who touched it? Who's responsible? Those are important pieces that we are capturing today with that data catalog. And it's important for one particular reason, and that happens to be something we call MDM, Master Data Management. Who created the data? Who's responsible for the data? Who has access to the data? Remember, that last one is very, very important. I'm going to give you an example of that where it becomes critical in an organization. We're going to talk about a hospital. Imagine you're out, maybe you're playing tennis or golf and you sprain your ankle, or at least you think you sprain it. You head over to the emergency center, walk into the emergency center, present your information, it's collected, right? So they collect information about you, probably your healthcare program, something else, right? Details of your injury. That information is captured today electronically. Years ago, it was not captured that way, but today it is. That electronic information is then stored and it's made available. Who has access to it? Well, let's think about this. You're called by the nurse to go to a waiting room. The nurse talks to you about your situation, captures more information. That information, again, electronically, most likely, through some kind of notepad or iPad maybe. There's lots of implementations of those in the hospitals. Let's look at where it goes from there. Well, it's going to go to the doctor, right? The doctor's going to review that information when they see you. They're going to cover all of the things that you mentioned. They're going to ask you about medications and so on that perhaps was written down by the nurse, but they want a clearer understanding of that, right? They're going to talk about other situations, right? How it happened, get details around that so that they can understand what may have occurred to your ankle. And then they're going to send you somewhere else, most likely to some kind of X-ray, maybe an MRI, maybe a CT scan, depending on the scenario of your injury. So the radiologist or whoever it may be, has to look at that data as well. They make notes in it. They provide, let's say it's the person taking the X-ray. The X-ray technician provides that electronic X-ray back into your file, and that's sent back to the doctor. You're sent back to your waiting room, or you're sent into the observation room again for the doctor to come see you. Doctor looks at it, says, looks like you probably just sprained it, but just for safety's sake, let's go and get this wrapped. So off you go to another area where a technician is involved with you and wrapping it. Of course, they put the details of what they did again into that file, and then finally the doctor said, well, now that we've got it wrapped, you're still in a bit of pain, so maybe we'll give you some pain meds for that. will write you a prescription. That prescription gets electronically filed, sent off to the pharmacy. Oh, and by the way, all of this information is captured by your, insurance, and all of that information is made available to the insurance company so they can pay out the claim, right? So there's a lot of people that are touching that data, your personal data, and we need to make sure that we understand where that is, right? From an audit point of view, where is that information made available within the team, outside the team, and even to third-party providers, right? Like a pharmacist or like your healthcare provider. All of those pieces are important for you and for you to ensure that that information is not found in the public domain. So there are, again, privacy laws, HIPAA, there's a whole bunch of other things that get enacted here. From the standpoint of this picture, that's all part of the data governance. So any part of this that is touched, including the lineage, right, over time, we need to have that information protected. Also, over here, any studies that we're doing on it, any statistical information that we're pulling out, we need to capture it and understand it, right? The healthcare provider needs to know, how much does it cost for this kind of, visit where we're simply wrapping somebody's ankle, because they need to know from a healthcare cost, what that's going to do to affect the bottom line. The hospital knows what needs to know, how long does that process take for staffing and other reasons, right? We're shy a lot of nurses and doctors today. So for staffing purposes, we may need to get PSWs involved or somebody else to help with that healthcare. And that's just one example, but data governance comes into play here because we need to understand all of the touch points within the organization where that data is, and we need to have a master data management plan so that we can track it over time. Who has access to, who's responsible, right? All of those things that we said were critical. Data operations is about the kinds of issues that we can have and how we can solve them in the organization. So one of the problems that we tend to have is the lack of collaboration. Remember, we talked about that a moment ago in DevOps, that collaboration can help the team be more efficient, more agile, quicker to develop and release changes that we require. Provisioning data manually can take a long time. So we need to think about ways of automating that, integrating that, and providing some kind of pipeline for that movement of data. We often have disconnected tool chains. What are ways in which we can now effectively create that pipeline with the tool chains that are required so the data can be managed better? We've already said there is often a lack of this, data governance, right? And that means that there's some kind of lacking in the organization for an understanding of what that is. Lots of great information out there. If you're looking for something specific around data governance, DMBOK 2 is the latest book on this, very similar to BABOK for those of you that might be business analysts or know about those areas, or PMBOK for project management. DMBOK is data management book of knowledge, and DMBOK 2 is the latest version. But certainly take a look at those areas. We have other courses on that. And of course, we mentioned data privacy here. So you can see at the center here, we have our DataOps, and the DataOps, by using the data engineering folks, working with the data integration, working with data quality, working with data security and privacy, we are really talking about an overall view of the data that we have within the organization. Now, remember, it's going to change over time. And that's because we make changes all the time to tables, right? We add new columns, we remove columns, we update the table, and we do a catus, where we create a table as a select from a table that currently exists, or we create a view which changes our outlook on the data. So that data lifecycle needs to really be considering how the data is being touched, what's happening with the data, where those pieces are being integrated overall. And today we have a number of ways of doing that. And I do want to kind of talk about what I've been showing you all along here, and that is some code. And one of the ways that we can automate these processes when it comes to data is through our code scenarios. The example that I have here is using AWS and using something called the Cloud Development Kit. Cloud Development Kit allows programmers essentially to write code, what we call a stack, that can essentially take our raw data, our data that may be collected here, that is available, and transfer it to the cloud, kind of in a single methodology. Now, what's cool about that is, A, that can be tracked, so we have the audit capabilities, but also if the data is changing over time, I can come in and start to modify the schema here for my table deployments. And that can be tracked as well. So when I check in my code, I can also check in the data that was associated with it. And vice versa, as that changes over time, I have that data lineage, or sometimes referred to as data lifecycle, for the data as it's making change. Here's a cool thing. If I go back in time, let's say 2 years ago, not only do I have the data that was being collected 2 years ago, but I have the code that was able to work with that data at the time. That's a key component. If we think about this from the data analyst point of view and the data scientist point of view, we can go back in time and see what they were doing as well, because we're going to check in that code that they wrote. Maybe it's a simple machine learning algorithm. Maybe it's something even simpler than that. Maybe it's just some code that they were writing at the time to understand the data and maybe visualize the data. So we've got all kinds of opportunity here. Speaking about the visualization of the data and so on, there's lots of ways that we can do that today. This example is based around AWS and using Amazon. Amazon has, of course, lots of tools. I could take the same example and show it with Azure. I could take the same example and show it with Google. But the idea is that I'm setting up some kind of stack, and I'll explain what that is, but a stack is just basically that code that we looked at there a moment ago that is able to work with the data that I'm going to share to the cloud. Again, we could be doing this on-prem, but I'm just using a cloud example since I have it at my disposal. My cloud data project stack, yes, that's the one that I showed you a moment ago. The code that is here gets checked into the cloud. It gets stored essentially in S3, and I'll come to that in a moment, but so does my data. I have a way of uploading my data that is here to my S3 buckets and making it available in the cloud. Now, since this process is being done in a way that I capture that information, I can get all kinds of insight into when changes were done, when things were updated. I can produce templates to redo the exact same thing that I just accomplished, meaning that if I end up losing that code, I can access it again and download it. I can track the events that were done, when they were done, what was done, right? All of these things are going to be very, very important for the organization tracking what's going on. We mentioned that with regards to AWS, we're storing the data in buckets. A bucket in this case is simply an object store where the object is referenced through kind of what looks like a path. We call them buckets. For instance, down here, I've got an example of some storage of data. This is representing the customer data, the employee data, the order details data, and the orders data. If you had quickly seen it flash over here, that's actually this data. Happens to be CSV data, but it could be in any format that we would have today. You can see there's data stored there. This is what actually gets uploaded through the process of my application. And from this process, of course, we can take advantage of that by storing it here in the cloud. Now I can make it available to anybody in my team by simply setting permissions on that data. You'll notice right now I'm the only one that has permissions for that. But again, bucket ownership, I can change this so that I can make it public accessible or accessible to members of my team or my group. Let me, again, just make that a little bit larger so you can see it here. But essentially, I can change the permissions here for those members of my team to be able to access the data. This is, again, a key component. From that, as I mentioned, the audit trail and so on is available. So we've got two ways of doing that. One through CloudWatch, where I can send out notification when somebody's working with the data, or somebody's touching the data. If I so desire, I can set alarms and so on if there's any issues with that. Here, of course, logging those events and so on. And then I can go one step further above that. I can actually set up a very high-level audit trail of that interaction. So what did they touch, what did they change, and so on. All the way through from people querying the data to people deleting, databases or other scenarios around my data here within AWS. That example data I've actually have here in the cloud. This is Athena. It's an SQL front-end tool that can be used to interact with the data catalogs. And you'll see I've got that company data here, and I can actually preview my table and look at my data. In addition to that, I could go a little bit further here on AWS. As a data scientist or data analyst, I could take advantage of something like, let's say, QuickSight, which allows me to model my data in the cloud environment. That's not to say that we couldn't do this as well through something like Tableau, which is, of course, a very popular tool for modeling today. And again, this is possible. So here in QuickSight on AWS, I can access my data by my area. So for instance, the data that you saw there a moment ago, I had uploaded to US West, Oregon. So here I'll capture that data. Just to kind of show you a very quick analysis of some data. Oops, this is would be an example of that. I've got a couple of other examples over in Virginia as well, whereby I can start to do my analysis and present this in a graphical way for the the individuals within my organization. Also available to share this, so we can save this data, but we can also share the data with others by publishing a dashboard essentially around our discoveries of the data insights that we're looking at. So you can see that moving the data is just one part of that overall operation, because then we want to get the data engineers involved. Perhaps the data engineer will be brought in. Maybe they need to fix the data in some way, right? That's something that we mentioned earlier. So I have an example of that over here on Databricks, which is also connected to my AWS site, but could be connected to Azure or whatever. Here we've got an example of some data that's missing. You can see the NaN information, not a number. And in this case, what we want to do is we want to fix that data. Maybe we drop a column. Maybe the data is just not, repairable. So we drop that specific column. Maybe we check to see how many columns are null, right? Maybe we interpolate the data in some way and maybe use a nearest neighbor method to replace the data that's missing with its nearest neighbor. This is kind of an example of that. Or maybe, we want a mean value to replace the value where there is missing information. All of these examples are using the Python language using PySpark, but we could do this in Scala or Java or even R if we required folks to have different backgrounds, right, in the organization and come together as a team to present the information. So we have a lot of different things that we can do around data and fixing data and so on, including some libraries here in Python called scikit-learn, which allow us to do label encoding and pre-processing of data. These are all part of a larger program that we offer organizations for data engineers and data scientists. So again, just giving you some insight into some of the effective things, whether it's just querying the data or whether it's using some kind of graphical way of representing the information. And again, all of this is configurable. We can come in and play with the visualization types here, at a simple layer, but we can also get very involved with the data that we're working with. Remember, that data started out as comma-separated values, and we've been able to transform it into a table that we can then use Athena to query against. To do so, we use some processing on that data that is done via what are called glue jobs. Glue jobs take advantage of Hive and Spark engines that can run against our data, and it can essentially create a crawler that creates those table schemas for us to work with. And you'll see some of that here in some examples that I have. So we've created a database, and we've got our crawler running to create essentially that data. And you can see here that's the customer data. Here is the order details data. Here's the employees data, and here is our orders data. All of those are essentially the tables that we saw here that were CSV originally. So DataOps is again concerned about this. The cool thing, as we said, we can check this in to a repository. That code is now in the repository. The data is being moved to perhaps S3 or Azure Files or Azure Blobs or Google Big Table or wherever that needs to be. And we've got the methodologies that were used to accomplish that. That life cycle or lineage, as we mentioned, is captured over time through this idea of DataOps that we are using here. So the integration, the engineering, security, all of that, and the quality of the data, which you saw perhaps that we do through creating mean or other methodologies to fill in missing information or correct the information in some way. As far as the roadmap today goes, we really need to understand what's available to us out there for the capabilities. I've shown you very quick insight into some of these, whether it's in the cloud. We could do similar on-prem operations as well. It really depends on the requirements within the organization. One of the key things is analyzing where we need to go with this data management. And remember, that comes back into the master data management plan that I mentioned earlier. That's a very important component. Master data management allows us to know of all of the data within the organization. We have a little bit of a problem today. I don't want to alarm you, but we have this idea of cloud first. Everybody's talking about cloud first. And what they're really saying is any data that comes into the organization, we want to put it in the cloud first, and then we'll start to deal with it. The problem with that approach is that without a proper master data management plan, knowing what data A has been uploaded, B, who is responsible for it, and having an auditable process for that, that's lacking. So organizations first need to think about data governance, metadata management, reference management, responsibilities, and so on. There are tools for this within the organizations. Talon would be a good example of this. IBM master data management programs would be an example of this. But we certainly need to know, where our current data is, whether it's in the cloud or on-prem. We need to know who has responsibility for it overall. Then we can start figuring out what is going to be required 6 months out, 18 months out, 36 months out within the organization. Because we've got a plan in place, because we've got data governance and master data management, that's easier to do. We can see who's touching the data, where that data is. Once we have an understanding of that, then applying, again, processes to it is going to be a lot easier. Fortunately, a lot of organizations don't have the talent yet. There's a big gap out there, folks, right now as well. When I looked at this gap in January, there was about 120,000 opportunities. It's come down a little bit. It's about 80,000 when I looked earlier this week. And those 80,000 opportunities are in data engineering and data science. Around 25,000 in data science, and 65 to 75,000, depending on where you look, for data engineers. The people that are responsible for moving the data, preparing the data for use by the data scientist. There's a big gap. In some cases, organizations are filling that gap by essentially getting the data scientists to do the data engineer work, getting the data engineers to do the data science work. This requires, of course, education around those fields, education around the tools and so on. So again, looking for the right talent and then educating them properly is a very important point that we need to think about. Once we have them within the organization, they can help us design that data processing workflow. Now, again, as a CEO, that's not my responsibility. I'm going to go out and find folks that I'm going to hire for those areas, right? Chief technology, when it comes to what we talked about with DataOps, but also here in DevOps as well, the chief technology officer. We may even have a chief data officer within the organization. So we would look for those folks, or somebody down the chain, right? If those aren't in place yet in an organization, a CTO and a CDO, then we look for others in the organization that certainly would be responsible for that. Remember, this is about here finding where the data is, transferring it, what the flow of that data is, what the consumption of that data is going to be, right? Because the latter piece here, the time to insight, is critical to our organization. I can't wait 6 months for information. I need to have it now, right? I need to have that information now. Without it, I'm going to have problematic issues here for that. Like you asked about where you can get information around the CDK project code. Yeah, absolutely. AWS, at least in this case, again, the CDK is only AWS. If you're going to Azure, you're going to probably run Azure functions and so on. AWS CDK, there's a tutorial. There's also examples. If you just do a Google search for that, you're going to find this is where the documentation starts. So, do start here. There's going to be all kinds of great examples here on different serverless applications. So that would be where I would kind of go as a kind of a touch point for that. I can put that, actually, let me put this one, the getting started one in play. As I said, if I'm in Azure or if I'm in Google, you would be looking at Google Functions. Google SDK, Azure Functions, Azure SDK. That would be the similar platforms for that. Yeah, absolutely. Yeah, thanks for that question. That's a good question too. These are definitely where you would be looking. Could I share an example? Yeah, absolutely. Let me just make that available to you. I'll give you a zip file because that's probably going to be the easiest for you to work with. Again, the expectation though, you would need to know a little bit of programming there. So I just want to make sure that you're aware of that. The one I'll share with you, the CDK example, is probably the best one to work with. Let me put this up. Again, you'd have to have some, oh, it won't let me share that. All right, what I'll do is I'll do a follow-on to the FTP link that you'll get after class, and I'll make sure that you get that. It's just saying it's too large for me to share with you here. Essentially, you have to have some things in play first. So on your local machine, you have to have, in the case of working with the AWS CDK, the AWS CLI, the common or command line language interface. This lets you do things like AWS S3LS, right? And I can go out and look at my buckets that are sitting there. So I need to have that installed first. I need to configure my application to allow me to log in remotely. So under IAM permissions, I have to have permission for that. There's a few other things that get involved here. But those are detailed in that link that I shared with you a few minutes ago. So that should be helpful at least. As far as who's doing what where, we know that there's that relationship that I just mentioned. As I started to say, we're seeing kind of a amalgamation of jobs because we're short on data engineers and we're short often in data scientists in the communities where these are required in organizations. Sometimes those roles get a little bit blurred. Recently, I saw one for an AI ML engineer. That's a pretty high level request. But again, these are things that are happening out there in the community and areas that we're starting to see a little bit of blurring going on. What we're really looking at is that extraction of the business insight and extraction of knowledge so that we can provide that to the business. We obviously, from a data science perspective, right, there's some kind of expected background here. Not all of that necessarily is expected for all examples, but certainly having a background in statistics, pattern recognition, machine learning, maybe not data warehousing, but certainly an expectation of that around the specifics of the organization would be required. So if your organization's using an on-prem server for storing data, then an expectation that you know how to access that, or at least know where the exposed endpoints may be if it's an API endpoint. Data visualization for sure, some minimal understanding around visualization techniques. I mentioned earlier Scikit-learn just to kind of show you the modules that are available today that help with this. This is in Python, Scikit-learn. You'll notice that it has a classification, regression, clustering. It also has pre-processing, dimensionality reduction. So you can go in here and get great examples of how these tools can fit in and be utilized by not only the data engineer, but in particular the data scientist. If we went in and looked at something under nearest neighbor, we would see some examples here. No, may not be appropriate to your organization. Again, from the standpoint of classification, we might go in and look at things like naive Bayes or decision trees. And again, I don't want to know the algorithms necessarily. Some of you may, I want to know how I can apply that using code to achieve essentially what that algorithm suggested to me. So here in code, we can see kind of an example. But these are the kinds of things out there that are helping, our data scientists and our data engineers focus more on the actual data and the work that they need to do with the data, as opposed to the, moving the data to where it needs to go and preparing it. Again, we've kind of got data science here at the center and all the supporting pieces that need to be part of that vocabulary, essentially, of that data science person. Data engineering just being one of the supporting roles, as it would be data analysts, BI, and so on. A little bit of a slide here on the data governance piece. I did touch on this a little bit earlier, so I want to come back and touch on it again here. I mentioned the DMBOK as being an important piece of what folks are using today. The Data Management Book of Knowledge from DAMA, this is the Data Management Society. This is an important book that you should reference. There's also an executive book. There it is. Navigating the Labyrinth is the executive book. So this gives you kind of a good overview of how organizations are using data management, but at the executive level. And then if you're somebody that's actually doing it, again, the data book here, the DMBOK 2 would be the one that I would look at. And you can see it touches on a lot of these things that we've been discussing, everything from quality to security to storage to modeling, kind of the architecture pieces as well. I can make that available as a link if somebody wants to go and look at it. You will sometimes find these at a cheaper price. They're pretty expensive. Just to say that if you actually become part of DAMA, you get access to these books. I don't remember exactly what the current fee is. It's around 300, or it was around 300. But essentially what we're talking about is this idea of quality, the data lineage, again, that archiving of the data over time. We've got this idea of interoperability. So, where is it available? Who's it available to? But we're also keeping track of auditing and compliance, which is very important today in the organization. We don't want to certainly be fined, as we said earlier. And we can be fined for really silly things, but the big one is moving data where it's not supposed to go, or exposing data, privacy. There was recently a couple of cases where that has happened, where the fines have been significant, like $750,000 was a recent fine that I saw because of compliance and security not being met. I don't know how many organizations can afford that. In particular, the other side of that too is that if the data doesn't become available, then what happens? There's a good example of that with Delta Airlines. Just as an example of what's been happening over kind of the last 10 years. Delta Airlines is based out of Atlanta, Georgia, and their data center was, a single data center was in Atlanta. You may or may not know of some of the things that have been happening in Atlanta recently, like the ice storm, right, that happened, and we've had some flooding from major hurricanes that have gone through the area. All of these have affected infrastructure. And of course, infrastructure is needed for storing data in a data warehouse and accessing it through the networking and so on. Delta has lost almost $500 million through 7 outages in the last 10 years. again, there's not many organizations out there that can afford to do that. And they're not the only airline where they had a single data center that was essentially being affected by these kinds of outages. And this happens quite a lot. When there's an outage like that, there's essentially a ground stop. And when that ground stop happens, as I said, this can cost an organization an awful lot of money. So, again, we want to kind of watch out for those kinds of scenarios. Well, that's not the responsibility of the data scientist or the data engineer. It's part of the insight that we get from data governance. Where are our vulnerabilities, right? And do we need to treat that data in a way that the risk is mitigated? How do we do that, right? A lot of organizations are, as I said earlier, going to the cloud first approach. Oh, well, we'll put everything in the cloud and everything will be all right. Again, we need to think about that further and really think about the risks that are involved, who's managing the data there, how it's being managed. These are all things that we need to take away. And DataOps is only one part of that solution, right? It's part of the master data management underlying the data governance, which underlines IT governance, as you see here, because it's a subset of it. So if we start to think about that, who are the stewards essentially of the data for the organization, and then second to that, where is that data going to be stored? Ideally, probably on-prem and in the cloud. Ideally, the sensitive data not in the cloud. So anything that involves data privacy probably kept on-prem, but reference made to it for the data that we do need to move to the cloud. Employee ID, customer ID, right? As opposed to the full customer information. All of those things are kind of important pieces when we kind of need to work with that. And again, these are areas that we would kind of focus on. Recommendations for extracting data insights programmatically. I would say today Python's probably the biggest language that's used. It's not the only one though. We've got Scala, we've got R. We can get insights with Java and .NET. So you'd probably have to think about within the organization, what are we currently using? So I can't really answer that specifically around your organization. But certainly Power BI, as you mentioned, QuickSight, Tableau, those are great tools for that. Power BI and Tableau can integrate directly with Azure as well as AWS and Google in the cloud. So, if that's something that you needed to do, it's certainly possible. As a starting point, I tend to use something like dbeaver. This is an example of dbeaver. It's a kind of a generic universal database manager. This is because I work with the management of the database itself. And you can see that I actually have a connection here to my data that is in AWS. I actually have others as well here to Snowflake and so on. But I can get at that company data. I can look at my tables specifically, like the customer table that we saw a moment ago. And if I double click on this, I can actually see the table structure. I can see some of the data. It's going to fetch the data from AWS for me. It's not a very big table, so no problem in doing that. But I can also see the properties of that table. And if I need to make changes, I can essentially do that here, right? Changing whatever the data type is, or adding a column or so on. That can be immediately updating my remote data store. So there's many ways to accomplish it. It doesn't have to necessarily be via a programmatic language. If you're using Power BI, again, or Tableau, these can easily integrate to something like Athena, and then allow you to query your data wherever it may be. the examples here we mentioned are in S3 buckets, so they're just CSV data, but we could connect to something like a data warehouse like Redshift. We could be connecting to EMR, Hadoop, MapReduce, and work with all kinds of data there. We could connect to RDS. Again, I'm using examples in AWS, but it could be any platform here that we work with. And there's lots of ways to integrate today, both programmatically as well as through those tools. So I would suggest you first look within the organization, figure out what tools are available, and then decide whether it makes sense on-prem or in the cloud to have those. And that's part of this idea, right? Where we once we know where the data is, then we can start to plan on how to access it. So going further to your question, how do we get insights programmatically? There's lots of tools out there for that. We're going to start off by getting the data there. So data ingestion, whether it's batch or streaming, real-time data streaming. Haven't mentioned yet, but I work with control systems, both robotic control systems that build chipsets, like memory, but I also work with building control systems that are controlling life safety, things like elevators and fire alarms, but also lighting controls and heating controls. And in those cases, we have both. We have batch processing that we do, but we also have real-time streaming data, in the range of 300,000 messages a second that we have to be able to work with and interact with, right? When somebody walks into the room and the motion sensor sees them, the light needs to turn on, right? To whatever level they want it, or the heating or cooling needs to turn on. In the case of batching, what I might do is, we actually do this, we have to do reporting, right, of how much energy was used by somebody, a tenant in a particular part of a building. So it might be, a 50-story building in our case in Vancouver, or Toronto, we've got a 30-story building there that we manage. And we might be able to take that data in, look at that and produce a report, right, at the end of the month of power consumption, so on and so forth, right? It depends on what we're asked. So in that case, I might need to do some extraction of the data that currently exists, prepare it for that month, right? Kind of partitioning it for that month. And depending on how large it is, I might need to put that into AWS in order to be able to run a clustered Spark job or a clustered Hive job in order to get at all the touch points and figure out, how much energy was used. Now, to be honest with you, we don't save that by second, because that would be absolutely crazy. So we do a time window of every 10 minutes in the building and store that to a data store that we then use with Spark and other tools to get at that information through the batch job. But again, it depends on what you're dealing with as far as the data goes. Storage, again, depends on what we're doing. If it's block level storage, then we're probably storing it, on a file system of some sort. If it's object level storage, I'm probably storing it in an S3 bucket or somewhere else that supports object level storage. And of course, when do I need to access it? We just mentioned, if it's real-time data, we probably need to be capturing it continually. Maybe I even need to use a queue like Apache Kafka or Flink so that I don't miss any data as it's coming in, right, before it gets stored in the data store. If it's on demand, where I'm doing my calculation on a monthly basis, I don't need to have that machine that's going to do the calculation running continually. I only need it to run when that calculation needs to be done on, the second or third of the following month. That rolls up all of the data from the previous month. So we have different ways in which we think about using data and applying it depending on the platform requirements or the customer requirements. And again, it could be done in many ways. when it comes to actually ingesting the data, in other words, getting it there, maybe we're going to do it with command line interface scripts like we saw, AWS CDK. Maybe I'll write that in TypeScript or Python. It could be other languages. It just depends on the organization. Maybe it's exposed by a web service, and I need to go and get the data, right, via some endpoint through the API that allows me to extract the information. In fact, that's how we do it, so that we can get it to the cloud. We have endpoints that are available from the building, and we can access the data that way. We could upload it through secure FTP. We could use Apache NiFi called Niagara Falls. It's a workflow, essentially. We could use Scoop. As it says, they're scooping out data using SQL commands. A Scoop is a tool for doing that. Allows us to work with both relational data and data warehouse data, which may be in some kind of non-compliant form, typically denormalized, right? So we may have to work with it in a denormalized way. You can see the streaming processes that we just mentioned a moment ago. I mentioned Kafka, which is a well-known tool here. If I was doing the same on AWS, I'd use Kinesis. There's lots of other tools out there. I recently wrote some material around using Azure and using event hubs, which are essentially Kafka in the cloud, and interconnecting that or integrating that with some other pieces in Azure so that the data could be maintained, right, as it's flowing into the system. Look, we could go all the way back to JDBC. I wouldn't necessarily say ODBC because that tends to be very slow, but certainly JDBC connectors, so Java database connectors to wherever our data may live, right? Often used for on-prem data, moving it to the cloud where we want to do it securely. This would be a good example of using that technology in some way. Sometimes it's easier to see this all as a picture. So I've brought in a picture here of who's touching what where, and this may help understand kind of those roles that we were mentioning earlier. On the far left, in blue, we have the data engineer, often working with the operational data, often working with integration programs, working with other external data. The idea is that they will cleanse the data and prepare it in some way. Let's not go too far yet. Let's say that we're at this point. They've cleansed the data. So you'll notice that our data analysts can come in and start doing reports by a reporting engine. Maybe it's SSIS or SSRS or SSAS, thinking along the Microsoft ways. Maybe it's SAS. Maybe it's some other tool that you're using. Doesn't really matter. There's lots of tools out there, some of them more expensive than others. And maybe they're doing other work, right? Maybe the data itself is being set up for transactional processing that they need to do with that dimensional data. So they'll do dimensional mapping of that and create queries, right? That's our result sets or record sets that we'll often see from the reporting engines, but maybe they prepare it ahead of time via some kind of view so that data is rolled up, right? We've got aggregation and grouping done of the data in some way. We start to move into the combination area when we get here, because data engineers, in preparing the data, they need to make sure that the data actually meets the requirements. So there is an expectation that they have some kind of insight into running SQL commands, but also some insights to do visualization of some sort. We mentioned, Power BI, QuickSight. We've mentioned others like Tableau, which is very popular out there. You could do this in Excel. I've taught, pivot charts and pivot tables for years because that was often a way that, data sampling was done. We pulled some CSV file out directly from an export of our SQL data, and we did some work with it. Or we pulled some data maybe through a third-party integration piece where we had to have our OLTP data along with our OLAP data, analytical processing data. The analytical processing data would come from that dimensional data that we've stored in the warehouse often. Maybe we create a data portal, right? And the data portal takes advantage of that. I've done some work with IRS in the US around this, and here in Canada around CRA. And the idea is that we take the real-time data that's coming in, and maybe we want to map that to be able to look up our 401k, for instance, right? So you want to know how much you've contributed over the last year, because before you contribute your next amount, right? Or how much your employer has. Whatever the case may be, we would create a data portal that's able to work with the OLTP data, the current data, as well as the OLAP data, so that we have a clear understanding of where our goal is going forward. Here is the most important part of that, and that's to look at some kind of feature in the data. And this goes into getting insight. Features are generally, I don't want to always say this, but they're generally some kind of column or some kind of value that we're interested in, and we're going to pull that information out, and we're going to start modeling with that. Maybe, if we're talking about customer data, right? Maybe we're talking about the types of sales around a particular product or service. And so we're going to narrow in our focus on the features of that. And then maybe what we're looking for is, how quickly are we able to take an order, process the order, and ship the order, right? So we're looking around a particular product in that case. We're trying to get some insight into that. Where are, our touch points in the organization that are causing that to be delayed? And so we would maybe model that in some way. Partitioning the data just means breaking it up so that we have some training data to start with, maybe about 20% of the data, could be a very large data set. We'll reserve some other data, and then we'll reserve maybe 60% of the data for testing. We'll talk about why we reserve some additional data there, but we break the data up. Now, partitioning in this case, mentioned earlier, we break things up by month so that we can do a monthly billing. Well, maybe that's how we're going to break it up here as well. Maybe we break it up by month. We partition that data. We set up some training analytics on it. Maybe we're going to use predictive analysis. That's a little bit higher level, but in my case, it's used a lot. We want to predict when something's going to fail, right? The example I always give is a chiller on top of the building is a very, very, very expensive piece of equipment that we want to not have fail in the middle of summer, obviously, because it's the air conditioning. And it may cost, $250,000 to $500,000 to get that equipment on site and to load it to the top of the building or wherever it's going to go. That timeline may be critical because in unionized organizations, we may actually have rules that say, if the temperature goes above a certain temperature, then employees should be able to go home, right? Somewhere in the high 70s, typically in the US, about 25 degrees Fahrenheit, Celsius here in Canada. That could be detrimental to the organization, especially since we're now trying to get everybody to come back and work, instead of from home in the office place. So being able to figure out or predicting based on scenarios that we're seeing over time, month of May shows this, month of June shows this, month of July shows this, I'm seeing a trend, let's get maintenance in, try and fix it. Can't fix it, we need to get into the supply chain now because it's going to take, months, maybe even a year before we can get that chiller on site. That could be detrimental to, obviously workplace safety and health and so on, which again, we can be fined for. So something that we want to know about. As we look at, these processes, we kind of need to think about how to bring them into play and how to utilize them today. Different tools here that we can take advantage of. We'll talk about some of those coming up. I would say, overall, most organizations today from the ETL process are probably using more scripting than they are actual efficient tools out there, but there's lots of tools from organizations like, IBM and Talon that I mentioned earlier. There's others out there that are used through the ETL process. But I would say it's actually higher to not using a tool and actually using a script. So just to, kind of relate that, at least from what I see. The idea here with the data scientist is, they're going to be able to give me that insight about when that chiller is going to fail through their predictive analysis, and I'm going to start to plan for that, right? Because that's going to be a capital cost outlay that I don't really want to have necessarily coming up. But we can see how sort of these fit together. And as I said, a lot of this is getting blurred because we don't have enough data scientists, we don't have enough data engineers, and so that blurring is happening here. So there's lots of training going on, really from this end all the way through, where we're taking folks that may have some experiences like DAs and making them into data scientists, less likely to take a data engineer and make them a data scientist, but we can certainly help the data scientist understand some of the data engineering process. And we do see that a lot in organizations. Just because of the requirements are a little bit different here. This is a computer engineering area, whereas data scientists, tend to rely more on the data science fields and areas around that. You can do it; it's not impossible, but less likely. Data processing systems. So you were just asking about some of the interoperability stuff that can go on here. So there's lots of tools. I would say probably the most prevalent one right now for cloud would be Parquet format. Parquet is a compressed format. If we were to use a text file that, let's say, is 500 gigs, if I was to take that same file and compress it into Parquet, maybe we're around 300 to 200, somewhere in that range, because the compression will allow us to ensure that the data values are, compressed in that file, and that's going to give us better performance overall. So there's a bunch of those tools out there that we could take advantage of today. Orc files are quite common as well. The most prevalent for data interchange, though, is of course JSON. The problem with JSON is it doesn't have a schema. So if you do need a schema, then you would go to something like Apache Avro, which is JSON essentially with schema. Again, this would be something that we would take advantage of here to work with that data. Again, we want to store them in some kind of interoperable format, because that means down the road when we need to work with it, we can then essentially pull it, right? It's not going to be our own generic format that we came up with. It's something that is an understood, recognized format available out there. And that's why we used to use XML, right? Roy Fielding's XML platform in the early 90s and early 2000s. As far as storage formats, our DBMSs aren't going to go away anytime soon. We still got those relational databases to use. We've got a lot of NoSQL. There's over 225 NoSQL systems today. We've got other types of databases as well. I just happened to mention GraphDB here, but there's certainly a good, breakdown of these types of data stores, making them, available to us depending on what our requirements are. If you were going to do ETL in the cloud, The nice thing about that is that there are tools that you can use for looking at costing, also for predicting the costing of these environments as well. So pretty much all of the vendors have some kind of calculator that you can use today to figure out the costing of that, since that's a question that came up. This is a kind of an example of that. This is the AWS calculator. Having said that, I will tell you that you should reach out to AWS if you're a larger organization, or reach out to one of its partners if you're a small to medium business, because they can help you understand the cost by comparing it to other organizations similar to yours. Again, the cost estimator is just that. It's an estimator. You can pick the type of service that you think may be appropriate, and then you can get a kind of a costing of that. And it will basically start you off with, you know, kind of a monthly cost, and then total that over the 12-month period. For instance, if we were running some servers, right, VMs, we could come here, look at the EC2 or Elastic Cloud environment, you know, cloud VM, whatever we want to call it, where we want to run it from, what kind of environment we're using. Notice Windows and Linux are available here. So let's say it's a Red Hat example, just to show you. And then we would start, how many, you know, CPUs do we require for, how much memory we require, maybe, you know, 16 gig. Well, that's, you know, kind of low end. If I was doing anything with ML or AI today, I'm looking at least a terabyte, so 1024 or better, and I'm probably looking at least GPUs here. 4 GPUs might be enough, but more likely I'm probably going to have like 48 GPUs. Oh, because of the instance type I chose. Yeah, it won't let me do it. It's only going to probably let me have a maximum of 8, I'm going to guess here. So there's kind of, you know, an example of getting some kind of program together. Then I'm going to look at storage. Well, if I'm dealing with terabytes of data, you know, a gigabyte here is not going to be enough. So I'm probably going to move up to maybe 12 terabytes. Yeah, that's probably going to be good. And you can see that I'm now at a monthly cost of $16,000 US. Now, some of you go, wait a minute, that's pretty high. But I can tell you to order that same machine is going to be about $500,000. So upfront cost versus monthly cost. And remember, I only need to keep that machine when I'm actually doing calculations or I'm running some kind of programmatic operation. So from that point of view, I can probably cut down my costs by stopping it when I don't need to use it, or setting up an on-demand instance instead of an upfront cost instance like an EC2 would probably be a better approach, what we would call serverless. So we can do serverless operations as well, and there's different types of serverless operations available to us. I think I mentioned functions earlier. So a function runs, and it runs at that point in time through a job that I start or an event that triggers it, and it's only going to run as long as it's needed, right? And I only pay for when it runs. I don't pay for having that machine sitting there 24/7, 365. So I can cut my costs down considerably by going through something like that. And there's all kinds of examples of, you know, things that do that, like Glue that I showed you earlier, the Glue tool that was able to prepare my table. I only pay for it when that job runs, right? As an example, I'm running a program right now on AWS, and we go back to my main window here. We should be able to see some of the costs involved, just to give you an idea. There we go. So my most expensive thing has been running queries against QuickSight, against my data, right? If I don't want to incur that cost of running QuickSight against my data, then I'll use a third-party tool and connect to that remotely, kind of like I showed you with dbeaver, where I can connect to the Athena engine and run my query. That will cut out $8 of cost, right? So there, there's different things I can do there. There's my glue jobs. I had 6 of them that I ran as an example this month, and you can see it was like 3 cents. Right? Other things, my storage, right? The data that's stored in S3, you can see it's pretty cheap to do that. Now, if we start to do a lot of it, right, a lot of storage, and we start to do a lot of building out of our tables for our data store, and we start to do a lot of QuickSight insight, then yes, the cost is going to go up. But overall, what was it there? $11.86 is a lot cheaper than going out and buying a $50,000 or $60,000 computer that I'm going to run those on. So this is again something that we need to think about. Okay. All right, I'll get off that. Okay, so again, things that we need to work on. I mentioned things that we have to kind of fix. So there's some examples there: missing values, inconsistent formats, duplicate records, outliers, things like this that are outliers where that could affect my outcome. I may need to decide how to deal with them, right, as a data scientist or a data engineer. We mentioned about setting up the data, so harvesting the data, cleansing the data, right, augmenting the data, normalizing the data. We mentioned all of those. All of those would be realms of the data engineer. They would be preparing it for us. There's a couple of examples there I threw in. Remember, you can download the handout that has it in. It'll also come to you after the class session is over here today. We've got computing services. We've also mentioned a few of these already. I just touched on those. So, physical servers or virtual servers that we may have. We talked about capital cost savings. We talked about containerized environments in the IT governance side of things, but it does come into play here with DataOps, because we are taking advantage of those servers, right, to do our storage of our data and, of course, the computations that we need to do. This could be in the cloud environment as well. Remember, cloud is pay as you go, as opposed to that capital cost upfront that we mentioned earlier. Things that we need to think about, what we call data physics. Giving an example of this, imagine that we're in the US and we're collecting all of our data in Virginia, right? There's a data center in Virginia. If I need to access that data from California or Seattle, there is a latency cost involved in that, right? The time that it takes to transfer the data from Virginia to my location in Seattle could be significant. In fact, it was quite significant for a project I worked on a few years ago with Microsemi. Microsemi makes the Adaptec RAID card. We own patents with them on that. Their designers are in Seattle and Burnaby, BC, but the actual chip and board is made in Bangalore, India. And we had latency times of around 4 hours from the time that the designer designed it to the time that it could be actually built, or starting to build the chipsets in Bangalore. That's something that we need to think about, right? So from a latency perspective, how does that affect our organization and working with the data? Okay, so again, just something I want to talk about there. So the physical location of the data versus where we're computing the data, right? That's the link between where your data is, where it's being processed. And of course, we try to do that as close as possible. So again, keeping in mind. There's also an example here of working with Hadoop. Hadoop, of course, being the distributed file system, and of course the resource manager, right? Schema on demand, so we have the data stored generically, and then we apply a schema on demand, as opposed to a schema on write, which is more the technique of an RDBMS, Relational Database Management System. You create the schema first, you create the table structure first, and then you store the data in it by inserting and updating the data or deleting the data. Here we apply the schema when we want to read the data. So it doesn't affect how the data is stored. Again, CRUD methods, select, insert, update, delete. Those are pretty standard. When it comes to doing this, I mentioned Hive earlier, we got Impala, we got Athena. There's all kinds of them that are used in relation to working in the cloud. So again, depending on what you need to do. We've already seen this, but I just wanted to bring it back. So from an ETL process of the cloud service, pardon me, we've got Glue and the Glue API, which is used for processing semi-structured or unstructured data, normally unstructured data. It's also a serverless application, as you saw. It runs and I only pay a minor cost to it. So be an example of creating a table and of course storing it as Parquet. So again, these examples are available for you to look at, and I've already shared some. Glue creates the catalog. Catalog is the database. It also can include the table, as we saw. We create a connection to that, and that connection that we use is essentially able to allow us to work with the data moving forward. So again, the scripts that we saw and the information that we saw. So there's a couple of examples of that here. We have our data store. Notice we call it a store because this could be an S3 bucket. It could be an RDS. It could be data warehouse. Let's call it EDW, Enterprise Data Warehouse, right? Wherever the data store is. And then we crawl the data, which is essentially building the data catalog. We can create jobs over time to do this, schedule them based on events as the data is changing. Maybe every day at 7 o'clock a.m., new data gets brought into the organization, the crawler can run, and it's able to look at that data for us. Again, we can integrate that, as you saw, with other things like Athena and QuickSight. So the Glue catalog can be read, and any backend source, right, our sources back here, can be amalgamated. This could also be streaming data. We just didn't mention that there, but it could be real-time streaming. All right. So DataOps is all about the logistical needs of the organization and supporting those through a team effort. Remember, we've got the data engineer, data analyst, BI folks, BA folks, we've got database administrators, we've got system administrators, we've got AWS, cloud administrators, all of those people that come together. And of course, we've got the storage, we've got the governance, we've got the missing data, right? And we've got the data physics, which all of those things need to be considered as we are working through it. Last part is on machine learning, folks. And really, this is the computer algorithms piece. We looked at sampling data or training data. We talked about that a moment ago. Pardon me. And we generally create some kind of projection of the reality of the world. Pardon me. Which is done by modeling the data. So we have to know what the business objective is initially. Machine learning has a life cycle. You may have heard we create a hypothesis and we start exploring the data. We create a model to predict the outcome of that data. We make sure that the model is reliable, accurate, and can be used, which is, by the way, the downfall of most models. There's a 60% failure rate of that. And then we need to monitor it. Monitor it over time. By the way, the failure is normally because somebody does this with a Jupyter notebook on a local machine and then expects that they can throw that over the wall, and operations can then use it. That's one of the biggest problems. So again, something we need to think about. Defining the model, and again, looking at the machine learning life cycle here. So MLOps is basically streamlining that machine learning life cycle. We define the business goal, as we just mentioned, right there. We access and cleanse the data. Again, that may be some of the job of the data engineer, but the data scientist would be involved. We build the machine learning model in some kind of machine learning language, on some kind of machine learning environment. Typically on AWS, it would be SageMaker. There's others, obviously, in the other environments. In SageMaker, we can basically set up a training algorithm. We do that here. You create your own algorithm, or you find one that's available. There's a marketplace for this today. And so from the marketplace, we can buy an algorithm. If we create our own algorithm, again, we're just defining it and then setting it up against our data. So we would have to figure out the type of machine. This goes back to our infrastructure questions. Again, that's why the data scientist needs to know a little bit about the infrastructure. And then, the data that we're going to use is basically brought in. So that's how we would set up our training. And you can see, you then tune it, you make sure that the schema is working, and then you validate it overall. And so the algorithms are done here. A lot of that's done with a notebook. Notebook is, again, just a tool that's used to run commands. Earlier, I showed you the Databricks notebook. You may or may not recall that. That's okay if you don't. But we did kind of use it for repairing data. We could also use it for processing data, or even doing some visualizations. So here, bringing in visualizations. Again, this is Databricks, but we've got a data store that's stored as our data. We've got a computation engine, essentially the VM that we're running on that has GPU. And then I'm running a notebook where I'm running commands, right? Commands that look like this. These are all Python based commands that are being used. And I'm working with some data. My data happens to be MTCAR's data from, pardon me, MotorTrend. But that's the kind of thing that can be done. We can visualize it in something like Snowflake today. We can visualize it in Databricks. Those incorporate data lakes where all kinds of disparate data sets can be brought into play. Or we can set up our data here in S3 and start to work with it through the algorithms, through training, and of course, hyperparameters that we add where we're looking for a particular parameter within the data set. There's other types of processing that can be done here as well. We can even hire folks to help us label the data as required. Labeling it allows us to understand the data better, right? They go through and figure out where those features are that we mentioned earlier. So a lot of this is going on by deploying that machine learning algorithm that we mentioned before. Again, links there if you want to read more about that. So it's a set of processes or sequences of steps that we're implementing in our code. We need to have that same code work in the production environment so that we can scale it out with our larger data sets. You can't load necessarily exabytes of data on a laptop or exabytes of data on my presentation machine. That's just not going to happen. I might be able to get into gigs or even terabytes, but the performance of this single machine is going to be rather slow. So I need to have something that's more performant. And that's where I'm going to create a cluster of machines, many machines. I'm going to spread the data onto those machines by partitioning the data and bucketing the data on those machines. That just means breaking it up, right? And then I'm going to run my individual algorithms on each of the machines where the data is present. That's a little bit different than SQL. In SQL, we gather all of the data to a single machine and we do our calculations or our reporting there. That I/O process of moving the data slows things down. If we can take the data, break it up on many machines, and then run multiple algorithms in parallel, we have faster performance. And so that's the scaling that we're talking about here, by creating data pipelines that are able to scale out and work with the models. And really, MLOps is the successful process of applying those models to multiple data instances. Reusability is going to be important here. So repositioning and repurposing is very, very important in MLOps. There's some graphic there, you can look at it as well. Again, we mentioned about huge amounts of data. We're not talking, terabytes, we're talking exabytes, petabytes, right? Sorry. I always spell exabytes wrong, but it's EXO. Right, exabytes of data. We have 35 exabytes of data that we have in the cloud in our organization, which seems like a lot, but it represents kind of 7 years worth of collected data that has been stored. The other thing that we need to track is the feature models. Remember, we said that the data engineer and the data scientists are looking at features. They're looking at the column data, right? Or they're looking at columnar data of some sort, trying to understand in that data, is there some insight that they can give to the organization to help it, right, be successful? Lots of organizations have made that mistake, right? Sears, right, didn't see that the future was online. Even though they had a catalog already available that they printed, they couldn't figure out how to change that into an online catalog that you could order from. Who replaced them? Amazon, right? Think Netflix, right? Blockbuster is out of business because their directors didn't have the foresight to see that everything was going online, and eventually, right, we now have streaming online videos. Their CEO saw it, said, let's do it. Their director said no. It's unfortunate. Monitoring, right? Deployed software. I need to know what's running. I need to know what's running where. I need to know where my data is. That goes back to DataOps. You can see the connection here. My programming that gets my data prepared from the collection of the information from the customer gets stored in DataOps. Now I'm accessing that information with MLOps all the way through the process. Debugging, we talked about real world data. Auditing, right? That's the other thing that's important. Oh, and by the way, the versioning is here. And remember, versioning is done by our DataOps folks. Well, we also need to do it in MLOps. It was also done in DevOps. You see the comparison. Teams of people working together from cradle to grave of the data lifecycle, of the ML lifecycle, of the DevOps lifecycle. This is why these areas are so critical today to have a clear understanding of how they fit together for a very large organization. As far as some of the benefits, we already said that there's better management of this data, right? It's that data lake of data where we've got all the disparate data sets, and now we want to bring them together. And I want to look at the RDS data, the relation data. I want to look at the NoSQL data, the logs, and I want to look at other information that's being collected. Maybe, a report that somebody's generated in Salesforce, right? Where they've given me a CSV file to look at. Can I put all of those together, and can I get some insight that allows me to understand what that represents? It's important. Of course, this means that we can accommodate the change. It means that we have tracking of the features. We said that a moment ago. This gives us reusability of everything, meaning that I can take a model that I designed for this insight, change it in some way, maybe just modifying the inputs, modifying the outputs, and reuse it over and over again. It's a great little diagram again here. I've quoted where this comes from on the idea of the build, the modeling, the control of that, the versioning and so on, and then the model deployment and integration. And these are key focus areas that we need to understand because they operate essentially what we call today as MLOps. The 4 areas: build, monitor, control, integrate, build, monitor, control, integrate, and we continually go through that life cycle within our major organizations. Just about to wrap up, I've got a couple other slides that you can take a look at in detail. Feel free to do so. It kind of gives you the idea of the use case through to model training, evaluation, and of course, this is the production side versus the internal side, the development side. We can see that deploying of the model is essentially what we want to do here overall based on the use case that we're generating. I also have a breakdown of the stages. We're going to go through these in a moment, step by step, but there's actually 6 stages here. We'll discuss what the 6th one is, but scoping, data engineering, modeling, deployment, monitoring, those are all MLOps stages that should be kind of understood. So the build, the control idea, the implementation idea, and the model monitoring idea that we talked about momentarily. So scoping processes, we said EDA. We also said that requires infrastructure for the operations at scale. So we need to have an understanding of where that is going to affect the organization, what we need to provision, how much it's going to cost. Remember, that's in stages. So the steps that get us there, and then the processes that ensure that that can be scaled up. This, I would say, by far is the downside of most organizations. They don't have a clear understanding of how to go about that route of getting it scaled. It works great on that individual laptop with 160 gigs of data, but when I try to throw in petabytes of data, it just fails. Right? How do I get it from that initial stage that the data scientists and data engineer are working with to scaling it out for ops? So we've got that idea of processing. We then have the deployment. So that's the packaging of that. A couple of them mentioned here around that. So on demand, we mentioned batch, and we mentioned, although we didn't really talk about this in detail, that this can be done on edge devices. Edge devices are the idea of getting it to you in the data physics layer as close as possible. So maybe on a mobile device or an edge device in the cloud that's closest to you. Packaging, you can see some stuff mentioned there. Python pickle files are often used for data scientists that are writing in Python. For those of you working in other languages like C# or maybe Scala, maybe it's a zip file or a jar file that you're going to use. But we also mentioned that the most common way of doing that is through Parquet formatting, the compressed file that's available in AWS. Scaling, and finally, this is the most important part. Remember, we said that development is done with something like Jupyter Notebooks or an IDE, but we need to scale that. How do we do it? Horizontally, vertically. Horizontally, of course, means adding more machines. Vertically, adding more memory, more CPU, right? More disk space. It's going to depend on the type of insights that we're looking at here as to what makes sense. And then specialized on-prem and cloud servers that have that GPU, NVIDIA or some other. We mentioned containers, and I also mentioned serverless. So we've got lots of choices here for scaling. We just have to figure out, based on the type of data that we're using, what makes sense overall. So data engineering, again, we've kind of covered this off, so we won't really go back over it. We know what that is, pardon me. Sorry. Modeling, right? Training the data, we've mentioned that. So again, a bunch of things there. In particular, the retraining after the fact as the data changes. That's an important thing to understand. We've got the concept of deployment. So deploying a package, maybe that's going to be in SageMaker, right, where we go and we create our algorithms here, or maybe we find algorithms from the marketplace. There's over 5,000 of these out here that we can take advantage of, and we would pick out the ones that make sense for the type of algorithm that we need to deploy for the work that we need to do. Again, deploying where, well, depending on the sensitivity of the data, going back to our data governance, our security and privacy, it could be to the cloud, it could be on edge devices, or it may be on-prem, depending on, again, some of those scenarios. And again, that's up to the organization itself. What tools to use? This is fun. There's many, right? We can write some scripts. We had a couple of questions around ETL. Pardon me, we can do the same around code libraries, and I showed you scikit-learn as one of those that's often used with Python. We talked about using QuickSight. We talked about Tableau, Power BI, anything that can integrate, that can help us understand our model, understand the model drift that can happen as data changes, and then repairing that. So these are things that we need to know. Are we overfitting the data, underfitting the data? Where's our bias? All of the touch points that machine learning and data scientists know about. Of course, monitoring, load balancing, those kinds of things. There's the bias that I mentioned a moment ago. Deployment, lots of solutions out there. We mentioned Prometheus and Grafana. FluentD is here. Some of you may know about the ELK stack or ELF stack, which is this is the ELF stack Elasticsearch with Fluent's D's package, with Logstash being the other for logging. There's others out there as well. Cloud providers, I showed you in the case of CloudWatch and CloudTrail. There's other tools in the cloud that are available as well. So we have lots of things that we are kind of looking at here. By far, we are only at the infancy of this, with a lot of people doing proof of concept. There are a lot of tools out there available to us today for ML and AI at scale. It's a matter of picking the right tools, picking the right environment, whether that's on-prem or in cloud. Knowledge is important, and shared knowledge. So again, MLOps, going back to the idea of collaboration, it's about that, right? It's making my ML model available to somebody else in the organization that will help them speed up their process of implementing and getting insight to their data. So again, productivity, automating, ML development, CI/CD practices for deploying the data and storing, of course, that versioning of the data over time, as well as versioning of our ML models, and then finally enforcing policies against bias and tracking the changes. Those are all major benefits of moving to MLOps. So we've seen now how DevOps, DataOps, and MLOps all share very common analogies when it comes to the deployment of the code, data, and models. We've seen how this can be effective for the organization. It's a matter of figuring out the tools that make sense for your organization, figuring out who the players will be, applying data governance and master data management programs within the organizations to ensure scalability, accessibility, responsibility, all of the abilities around things that we need to track for, again, governance of the data. And I want to thank everybody for joining me today. I hope that this insight was useful. I hope we've been able to touch on a number of features. This program is recorded, so you will be able to go back and watch things. You will, if you haven't done so already, be able to download the notes, the course notes. I'll try to make the CDK piece available as well. There are links in the chat. Please do, feel free to go through them. And again, I want to thank you for the questions as we've been going through. I will open the floor just to see if there's any additional questions, but we are essentially done for the day. If you want to know more about WebAge and services that we offer, including courses, you can simply click on the links. You'll find areas around DevOps, DataOps, and MLOps programs at WebAge. So thank you, everyone. Thanks for being with us.